Hello, welcome back. Today we are going to learn about this chapter 6, form 3, experiment 6.1. So previous video we already learned about the this thing, the explanation, and now we are going to look at the result. Based on the result experiment, what is the effect of brightness of the bulb NP more than N? Okay, we look at V. V means volt. V volt. So VP is volt for the primary, and VP volt for the primary. Vs is volt for the secondary. N is number of turn in the primary, number of turn in the secondary. So what is the effect of the brightness of NP bigger than NS? Means the number of turn for the primary is more than number of turn in secondary. Means primary, if I want to draw out primary, secondary, the number of turn of coil is many. How to draw many? Like many many, and the secondary one will be little bit. For example, so from here we can see from high voltage to low, correct or not? Here will be high, here will be low, so the brightness will be lesser for NS, primary and secondary. So the primary will be brighter than the secondary. We need to look at the experiment. P is for, the reason they put P is primary. The reason they put S is for secondary. So it's easier for you to understand. Primary, then only you go to secondary school. You go to primary school, then you go to secondary school. So the primary is the first one. Not you go to secondary, then you go to primary school. So primary means the main. So if number of turn in primary is more than number turn of secondary, obviously MP is brighter than S. Can not? Bulb P is brighter than S. Bulb can make sense? What is the relationship of V and P if number of P is higher of number of S? What's the relationship? So the relationship is the number of turn. The relationship is the voltage, because you say the number of turn is higher than secondary coil, so of course this one, the voltage will be higher than this one. Okay, so I just write the voltage for primary is higher than secondary. Make sense? Hope you can understand. If you don't understand, you can ask, and I will reply you. What type of transformers is this? So we got two types, step up or step down. So the answer will be step down transformers, because from high to low, correct or not? This whole question is from high to low. Because how I know? Because you say primary is more than secondary. This question, before I do, you must agak-agak know this thing first. This question, wait, let me read. What is the effect of brightness of NP smaller than NS? Means the number of turn in primary, is less than secondary. So I cannot draw so many. Draw a little bit. So I draw a little bit. 1, 2, 3 lah. Primary, secondary. So I know in this question, secondary is more. So I draw more lah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So from this question 2, I know that it is from low to high. Okay, this is low to high. This is a step up transformers from low to high. The brightness in secondary is more than the brightness in primary. Why? Because the number of turn in the secondary is higher than the primary. Okay, that's the number. So you have a higher voltage, lower voltage for the primary and higher voltage for the secondary. Okay, now we know the concept already. We're going to dive into the question. What is the effect of the brightness of this one? They put this one is making people confused, not making the student confused, making the teacher confused also. But never mind, sometimes the question is like that. What is the different effect of brightness if NS is more than NP? Means secondary is more than primary. Secondary more than primary means the brightness secondary more than primary. Secondary more than primary. So I already draw for you. So this one is brighter. Correct or not? So the bulb P will be brighter. Okay, the bulb will be brighter. Bulb P, bulb P will be brighter. Wait, let me read the question again. What is the effect of the brightness if bulb number of turns in the primary is lesser than the secondary? So here will be brighter, here will be less bright. Okay. Brightness of MP smaller than NS. Okay, so bulb, which one is brighter? This is brighter. So this is P, right? So this is P. This is S. So bulb S will be brighter, correct or not? So BULB, bulb S is brighter. What is the relationship of NP and NS? What's the relationship? The voltage for P is lower than the voltage of secondary. Okay? The voltage of primary is lesser than voltage of secondary. Make sense? What type of transformers is this? Correct. Okay, so this is step up transformers. Why step up transformers? Because it produces from lower input to higher input. Why step down transformer? Because from higher input to lower output. Okay, what happened to the change in voltage of the alternating current in the transformers if the difference between the number of turns in primary coil and the number of secondary coil is increased? Means the difference increase, means here more, here less, or here more, here less, so the gap is bigger. So if the gap is bigger, so the difference of voltage will be higher. Difference of voltage will be higher. Correct or not? Because you make a gap, so the difference of voltage will be higher. Okay, this question is a bit tricky. I don't know, because I also don't know how to explain this question, but I try. I try. Okay, we need to, before we answer, we need to understand the question. And from question 3, I feel that student will not confuse. Don't know what the question is asking. Okay, so I'm going to read slowly and we try to understand the question. What happened to the change in voltage of the alternating current in the transformers if the difference of turn in primary and number of turns secondary is increased? So they are not talking about the number of coil. Actually, this question should be improved lah. They are not talking about primary 1 I put more, primary 2 I put secondary I put more. They are not talking like this. They are saying that, how to say the difference increase. That's the keyword. The difference increase means that the difference of turn increase. Let's say 20 and 10, the difference is 10 because 20 minus 10. So the difference of these two wire is two transformers, primary and secondary, is 10. If I put 50 and 10, the difference is 40 because 50 minus 10 is 40. If I say the difference, let's say here is 80, this is 40, the difference will be 80 minus 40, I get 40. So that is the difference. So that if they increase the difference, more become less or less become more, I don't know. But we know the difference is increased. We know that the difference in voltage also increase. Okay, you get what I mean? So yeah, I already tried my best lah. So if you don't understand, then never mind lah. But I mean, how to say the question, the problem is the question, not the answer. You need to understand the question is not clear. It's not clear. Yeah, I also don't know how to explain but it's never mind, it's okay. But I don't want to use too much time to do question 3. After you finish this chapter, then you will look back and then you will say, oh, it's like that one. Okay, so it's okay. And leave a comment down below if you can explain better for question number 3. Why are the number of turns in the primary and secondary coil different in all transformer? Why are the number of turns primary and secondary is different? Why? Of course you want different. If you got no different, then what you do? Correct or not? Means you do nothing. Let's say here 10, here 10, all the same, then 10 watt you get back 10 watt, then why you want to do a transformer? Better you just take a wire connect easier. Correct or not? So it makes no sense. If the primary and secondary coil is the same, so if it is the same, so there is no change, so you just use wire. Wait, let me read the question. I forget the question already. Why the number of turn is different? Because what? Because if the primary and secondary coil is the same, it will produce no difference of voltage. It won't produce difference of voltage. This one I add myself one, this one I add myself one, this answer. It is no difference than a common electric wire. It is not a transformer. You get what I mean? Because if you put the same, then it's a wire lor. It's not a transformer. It's just a wire, and you're wasting money because you need to use the metal wire so cheap, and then you want to buy the transformer to do nothing. So yeah. So now we know transformers already. To change the voltage from high to low or low to high, up to you. How you want to put. You actually can terbalik it one. High to low, if you terbalik, we will get low to high. A lot of function in these transformers. A lot of function. Let's see. Here got a lot of function. Yeah. Let's see the function. Function of transformers in home. At home, you got an alternating current of 240 volt. Probably can kill a person, but it can kill a person, but also not easy lah. I want to die by 240 volt, but it can kill a person. So we need to be careful of the electrical thing. I like to do electrical thing in my house. That's why I got test pen. You know test pen, so you need to test. Got light means got electric, no light means no. At down there lah, in my storeroom. So hopefully this chapter you learn. If you're a guy, girl I don't recommend do electric lah. Guy I always recommend do electric. Girl also can do lah, but I scared it's dangerous. So that the house electric thing spoil, you can fix it by yourself. Okay, and we look at this. This is transformers. We can see in the component is a transformers. It's a step down transformer. Especially you can see your phone charger. Why so big your phone charger? Of course lah, you want to reduce the current. Or the laptop, I also got transformer. The laptop got the big square thing, and your charger also got the big square thing. If I don't want to use this square thing, your phone will be very fast spoil. Because you don't believe me, you do. You put this wire and then you cut and then you put into the 3-pin plug, you plug. This phone, how many electric just will be like, this one is 15 watt, means around, let's say lah, 5 watt 2 ampere according to the power bank. You still remember 2.1 ampere 5 watt your power bank. Fast charge will be higher lah, 3 ampere 5 watt for example. So it depends on even more higher charge, like Huawei is the fastest charge one. 40 watt. This my phone is 15 watt. So you want to reduce it so that the electric go in slow. You don't want to put in 240. You put in 240 爆炸 lor. Your power bank only say 5 watt. You want to put 240 then the phone will straight away spoil. So we don't want that. Okay, it depends on what device you want to use. Okay, and induced current means the current, the electric. Again, I said volt, current, these two add together become electric. Volt, current, these two add together become the electric, the watt. It's known as induced current. The coil in the transformer is known as eddy current. The formation of eddy current in transformer will reduce the efficiency of the transformer. Due to this, the laminated iron core is used to reduce eddy current and increase the efficiency of transformers. A laminated iron core is made of layer of soft iron and layer of insulator arranged in alternative. So this is a laminated iron core because this one is to reduce the what? Reduce the efficiency. I mean to increase lah, make it more, because your efficiency will be lesser due to eddy current. So I will not explain the eddy current because later it will be like a very long another video for to explain eddy current. So we just want to make it best lah, okay? So we want to increase the efficiency and reduce eddy current. Okay, so we got laptop, we got transformer, we got phone charger, we got transformer, and we got the fan, we got transformer, okay? Everything got transformer. Either step down, obviously these three is step down lah. Step up, I'm not sure, maybe aircon you need to use transformer to step up the electric. Solving problem related to transformers in life. Okay, so this one is the common fan at our house. So we want to step down because we don't want the electric to be so high. So we can do it like this. By doing like this, you can see it can actually 1, 2, 3, 4, 5. So 1, the voltage for example is 2, 2 is 4, 3 is 6, after that got 8, and then 10 watt. So eventually you can control the watt by using transformers. Because you want the fan to go up higher, you go to 10 watt. You want it to be low, you just turn and it become lower. It's very good and very safe to use, correct or not? There's insulator, there's electric. I mean it's safe to use in the transformers. Okay, now we already learned the formula. This formula is the same. So instead of using the ratio formula in the previous video, I'm talking about the previous video, the formula is Vp over Vs is equivalent to Vnp over Ns. Vp is volt, volt, P is primary, Vs is volt secondary, Np is number of turn primary, Ns is number of turn secondary. Okay, so let's do this question. Okay, the book already give you example of question. The book will give you a question of, this is a symbol of alternating current, 240 watt. This is Malaysia. Other country different. Only Malaysia follow UK. China one is different. That's why you see China one, the plug also different. But you go to UK, you will get the 3-pin plug. But don't worry, UK plug is more safer, okay, because we got 3 pin, we got 1 earth wire. China one only 2 pin only, so actually 3 pin is safer than 2 pin. Okay, so here we can see 120, here is 40 watt. Now they ask you, this is X, how many? I don't know. But the formula say Vp over Vs equals to Np over Ns. So I just write Vp over Vs equal to Np over Ns. Vp is 240. Vs is 40. Np is 120. And F is X. So again the ratio formula, this one times this one divided by this one times this one. So 240x equals to 120 times 40. X equals to 120 times 40 divided by 240. So I will get 120 times 40 divided by 240, I get 20. So here will be 20 turn. Of course, you can do the formula, you still get back the same thing, 20. Yeah, okay, so this one will be the formula. It's the same like ratio actually. Okay, the first video we also got do ratio is actually the same thing. Like for example, if I want to do the ratio 240, 40, let's say 240 equals to 40, and then 120 equals to x. 120 equals to x. So x equals to this one times this one divided by this one. 120 times 40 divided by 240. So you still get back the same thing according to the ratio. But the formula is this one lah. You want to remember the formula also can. The reason I teach the ratio because in the first video, because I hope that you can understand the concept of the electric thing. Okay. Okay, let's do this very fast. What is a transformer? Okay, so yeah, a transformer is a thing device to change spelling error voltage of alternating current. Either you want to change to higher or you want to change it to lower. Transformers only function using direct or alternating. Okay, alternating current, very good. Only change alternating current. In a step-down transformer, the number of the primary is more or less than the secondary. Okay, in a step-down transformer, we know that it is more. Is used to change 25 to 250, make it higher. So step up or step down. Okay, step up transformers, very good. D, transformer at a fixed radio. Step up or step down? Step down, correct? Step down. In the radio, correct or not? Your radio, of course, you use lesser electric. You don't want to use. Your house is 240, you know. You can imagine 240. I think the only thing that can use up to 240 is the aircon. Because aircon, you know lah, when you turn on the aircon, you take the electric become 加多100块一个月 because of one aircon. 2 aircon in your house means you add 240. Other than aircon, I think every device in computer or in light actually use very little electric. That's why sometimes the uncle very difficult to talk to. Sometimes you on the light, you don't off also, or fan, it's okay. The thing that really must off is aircon. Really must off. Aircon, iron 烫衣服 hot 煲水的 okay, to boil the hot water, that one you need to off. The fan, the light, if you on little bit a while also never mind, because it don't consume a lot of electric. Only state one example of electrical appliances at home, step up and step down. Okay, for example, like oven, microwave oven. Because oven you use a lot of electric oven. And step down, what is the example of step down? Radio, or usually I just write phone charger because it's more common. Radio also can. Radio. But nowadays, very got people use radio. The reason they say radio because the person that write this book is uncle. You uncle, auntie, then you what you still use the radio. But nowadays, very got people use radio already. I think one day radio will disappear. Figure 1.8 show a transformer 5 volt and a mobile phone charger. Yeah, most phone is 5 volt. I don't know iPhone, but I know Android. Android is 5 volt. My phone also is 5 volt. Charger is 240, so it's quite high. I don't want to make the phone spoil. That's why sometimes I buy charger, I buy good charger. I don't want to buy the cheap charger. If you buy the cheap charger, sometimes the 5 ringgit charger, you can buy at Pasar Malam 5 ringgit. Please don't buy that. Because you buy that, sometimes the transformer spoil. When the transformer spoil, never mind. The thing don't spoil, it straight away go to your phone 240 watt. Straight away go to your phone 240 watt. You can say bye-bye to your phone. Then your phone got problem, cannot charge already. Then you go to usually here also got a break circuit. So you put in, you cannot charge. You go to repair shop. So it will take 100 and 200 to repair your this spot. But why you want to do that? Because you just save 5 ringgit to buy the charger at Pasar Malam, but you pay so much money to fix your phone. So usually charger I buy a good brand maybe 20 or 30 ringgit, a better brand, fast charge a bit, calculate properly. Now you know science already. See your phone spec, know your phone spec, voltmeter, and one more is ampere. When you go to buy your charger, then for one more is A ampere, let's say it's 2.1, sometimes it's 3. Huawei one is more, 5 for example. Read properly and buy. For example, your phone is 3 watt, 5, this one, okay, then you buy like this, then ngam low, you know, or because some charger is very expensive, because fast charge phone fast charge phone more expensive, but your phone is slow charge, you want to buy fast charge for what? You waste money. Just buy what your phone supposed to take for the electric. iPhone I don't know iPhone I think it's very common, but Android you need to choose properly. So figure show the transformer in a mobile phone. Okay, you cut already, open for you, you can see. Wow, this is Nokia, is it? The charger very old. Calculate the number of turn in the primary. So use the formula, calculate for me. Okay, so this formula Vp equals to Vs over Np over Ns. Vp is, I don't know, I put X. Vs is, what I'm doing wait. Vp is 240 Vp. 240. My handwriting. Vs is 5 watt. 5 watt. And P is, I don't know, I put X. And S is 10. So X equal, I do shortcut a bit X equals to this one times this one divided by 5. 240 times 10 divided by 5, you will get 480 after you press your calculator. 480. Oh, this is your answer. Is the transformer in the mobile chain step up or step down? Wei Chen? So it's a step down transformer. Why? Why is it a step down?
因为它的 primary 比较多。
Yeah, because the output voltage is lower than the input. Okay, so I just write, okay, the output voltage is lower than input, or I can say that, like what you say, the number of coil turn in primary is higher than number of coil turn in secondary, for example. Okay, so that's it for this video. I hope that you learn. Do more exercise. If you can buy book, do all this formula, because I think exam will come out. It's a common question. If you don't count objective, it will come out in subjective. And this question is a bonus question actually. It's not really difficult to count. Some students think it's difficult to count, but if you understand, it is a bonus point to get in your exam. So that's it for today's lesson. I hope you enjoy it, and I see you next time. Bye bye.